A lot of the trends between the SPDF blocks have a lot to do with their placement on the periodic table. S-block elements are basically where the last electron enters the outmost s orbital. The single s orbital can be occupied by a maximum of 2 electrons, thus there are only 2 groups it can hold since the number of electrons in the shell increases gradually as you go right to the table. An example element to represent s-block elements is francium. The element is metallic, meaning it's malleable, ductile, conductive to heat and electricity, and it's soft. This element has a low melting and boiling point due to its large size of atom and atomic radius. Helium and hydrogen are exceptions to these characteristics, as they are s-block elements but carry characteristics of different elements. P-block elements are where the last electron occupies the p orbital. They are in 6 groups on the right side of the table. The orbital can hold a maximum of 6 electrons, hence why there are 6 columns of p-block elements. There are 3 suborbitals in a p shell that hold 2 electrons each. The first group, which is 13, ends with np1, all the way to group 18, ending with np6. These elements come in either a metal or non-metal form. However, one p-block metal is thallium. It has the same properties as the last, good oxidizers, and it is less electronegative and not as reactive as the other p-block elements. Also, it has a high melting point due to its interatomic metallic bond, as in, the stronger the metallic bond is to the nucleus, the harder it is for it to break. The non-metals, although, would probably be the complete opposite. D-block elements are elements in which the last electron enters any of the 5 d orbitals. A d subshell has 5 d orbitals and can hold 2 electrons, thus they accommodate 10 groups of d-block elements. Starting at group 3, the ending is nd1, all the way to group 12, ending in nd10. All these elements are transition metals, like tungsten for example. It is hard, lustrous, malleable, ductile, conductive with heat and electricity, and has a high melting point and boiling point with the same reason as before. It is more on the left side of the spectrum, thus the lower ionization energy makes it less reactive, and actually immune to a lot of substances like acids and gases. F-block elements have the last electron entering any of the 7 f orbitals. Each of these orbitals can hold 2 electrons, which accommodate 14 groups on the periodic table. At group 4, and the ending contains NF1 and increases all the way to NF14, going from left to right. These are actually very similar to the D-block elements in terms of properties. An element like europium is a metal that is soft but heavy with high melting and boiling points, and all lanthanide elements have an oxidation number of 3. Overall, with some exceptions, based on an element's SPDF configuration, it is fairly easy to determine its characteristics with the help of general periodic trends as well. Hope that answers the question.